This video is going to be about 3D coordinates. So you can see here that I have a normal grid, and you can see we have the x-axis horizontally and the y-axis vertically. So for example, this point here would have coordinate 1, 2. Yeah, 1 on the x and 2 on the y. Now for 3D, what we can do, instead of having a flat surface like this, we can make it 3D by adding an extra dimension. So I'm going to do that. And we have x-axis here, y-axis going vertically, and we can introduce a z-axis, and you'll see what happens if I rotate. You can see now we're going to have three dimensions, okay, which means we can put coordinates in 3D. So for example, go over to here, if I put in add an object here, point, and you can see the point 0, 0, 0, 0 is actually at the origin, yeah? 0 on the x, 0 on the y, and 0 up on the z. So let's change that to something else. So for example, let's say it's 1 on the x, 2 on the y, and 3 on the z. So obviously you can see it would be up there, yeah, because it's basically 1 on the x-axis and then 2 on the y-axis. If you did it from the side, you'd see that's at 2 on the y-axis, and obviously 3 squares up, so it's kind of a point in 3 dimensions. Okay, so let's do another point. So let's make it more interesting by using a negative. So let's say -1, 4, 2, something like that. Okay, so you can see that this point is over here, yeah? Because again, it's -1 on the x, yeah? 4 on the y, yeah? And then 2 on the z. So you kind of can see that if you rotate it. Now the two things that we need to know how to do is how to work out the distance between the 2 points. It's just a formula. And the midpoint between these 2 points in 3 dimensions, and again it's just a formula. The formulas are basically the same as the one for 2 dimensions, just with the x and the y, but just with an extra thing in it. I'll show you now. So let's go to this. Okay, so these are the formulas. Okay, so let's do an example. Oops. So let me take 2 points. So obviously in 3 dimensions you're going to have the x coordinates. So let's say 1, 2, 3. Let's just do that one. Let's say that's 1 point, and the second point is at 5, -3, 1, something like that. So the thing about this is that obviously we have 2 coordinates, yeah? So each one has an x, a y, and a z. So this will be x1, y1, now z1, and this will be x2, y2, z2. Okay? That's how we label the points. Exactly the same as the thing that we do in 2 dimensions, except for now we have this added z coordinate as well. So you can see actually, if you remove this part with the z in, it would be exactly the same formulas as we would have in for 2 dimensions. Yeah. So let's go through this one. So let's find the distance first. So according to this formula, square root of x1 minus x2. So we're going to do 1 minus 5. Doesn't matter which way around you get them actually, because you're going to be squaring the differences anyway, but let's just keep with the formula. So x1 minus x2, so 1 minus 5 all squared, plus y1 minus y2. So be careful here because it's 2 minus -3. So this is going to be 2 plus 3, which is 5 squared. And then we have z1 minus z2, so 3 minus 1 squared. Okay, and then we just tidy that up. So this is 1 minus 5, that's -4 squared. 5 squared. And 2 squared. in these cases we don't, when it's positive we don't really need the brackets here, but this one we would. So it's square root of 16, 25 and 4. So that is square root of, so that's square root of 45. Okay, and then we could just work that out on the calculator. As a decimal, I'll tell you actually, square root. So it's 6.71. That's the distance between the 2 points. Okay, the other thing we need to know about is finding the midpoint. And again, we're just using this formula, which is the same as the one we did for 2 dimensions. It's just that we've now got the z. So remember, it's just the average of the x coordinates, average of the y coordinates, and now also average of the z coordinates. So it's going to be 1 plus 5 divided by 2, 2 minus 3, all divided by 2, and 3 plus 1. So you're adding them together, the numbers. Yeah. So this will be 3. This will be minus 1 half. And this will be 2. Okay, so this would be the coordinate of the midpoint. Okay, so for midpoints you're adding and dividing by 2. For the distance you're taking the difference and squaring each of the coordinates, and then finally square rooting the answer. Okay, let's have a look at a question, the only one I've seen basically in the recent exams on this 3D thing. So an inclined railway travels along a straight track on a steep hill as shown in the diagram. So you can see we've got x-axis on the bottom here, y-axis here, and z-axis going up. Okay, so it's kind of like rotated of what we had. So let's have a look at the question. So the locations of the stations on the railway can be described by the coordinates in reference to x, y, and z-axes, where x and y are a horizontal plane and the z-axis is vertical. So basically this bottom space is called a plane. Yeah, so that's the horizontal plane. We actually have the x-y plane at the bottom. This one on the side is the y-z plane, and this is the x-z plane, just where it's kind of the corner points, the corner sides of this thing. But anyway, the ground level station A has coordinates this, B has coordinates this, blah, blah, blah. So the situation doesn't really matter that much. They're just asking us to find the things using the formulas, basically, in A and B anyway. So find the stations, the distance between stations A and B. Okay. So again, we're just going to use that formula for the distance formula. So the distance is going to be the square root, and we're subtracting the coordinates. So this is, we can say this is x1, y1, z1, x2, y2, z2. Okay, so 140 minus 20, 15 minus 2, 15 minus 5 squared, and 0 minus 250. Okay, so we're going to get square root of, so this is obviously, you can just stick this in the calculator as it is actually, but I'll go through it more detail. So 120 squared, it's probably actually safer to put all this in the calculator and then work out the answer. This one obviously minus 250 squared, but minus 250 squared is the same as 250 squared actually. So then we're just going to work out that that's the square root of, I'll just do it on here. Okay, so that's the square root of 77,000, and if we do that, it's 277.488 7385, which obviously is 277 to 3 significant figures. Oops. Yeah. Okay, so that's the answer to A. B, it says station M is to be built halfway between stations A and B. So we're basically trying to find the midpoint between the two. So we're going to use the midpoint formula, yeah? x1 plus x2, so 140 plus 20, all divided by 2. Now we add the y coordinates, divided by 2, and then we add the z coordinates, and divide by 2. So we've got 160 divided by 2, that's going to be 80. This is 20 divided by 2, which is 10, and 250 divided by 2 is 125. So that's the midpoint. So this is M. Right, write down the height of the station M in meters above the ground. Whenever it says write down, it's got to be something simple that you don't really need to do much calculating for. What they're testing for is if you understand what this distance is onto the bottom of the thing, yeah? So this distance going from here. Well, obviously the bottom, the ground, yeah, is this plane here, x, y. So obviously the height is just the z coordinate, yeah? The height of the ground is the z in the z direction. So the answer to part C is just 125 meters.